Said a slug travels 3 centimeters in 3 seconds. A snail travels 6 centimeters in 6 seconds. I saw lots of things I liked when I was watching these ones. I saw ratios. People had slug 3/3, and that's centimeters and seconds. And then they had snail. I'm going to put SLSN. They had 6/6 cm and seconds. Now the work from here could be different, but our answers should all be the same. So it says both travel at a constant speed. My says the snail was traveling faster because it went a greater distance. Do you agree? Explain or show your reasoning. What can my work be? What can my work be? To compare, I need these to be comparable, Cam.
You can divide the snails.
Okay, I could divide the snails down to where it's divide by 2, so I can get them to have something the same. When I try and get one of them the same, what happens, Brant? It's easier to compare. What do we notice? Emmett?
The numbers are equal.
The numbers are equal. What does that mean?
That the slug and snail traveled the same.
Yeah, that means they're going the exact same speed. Okay? So you could have had your work like that, and you would say, I disagree with my because the snails are going the same speed. What else could my work have looked like? Maya? Yeah, we could have, by 2. We could have done times 2 times 2, and we would have gotten 6 to 6. Would we still have gotten the same answer? Yeah. Someone, I don't remember who it was, said both of these are equal to 1/1. Do you agree? Do we still get the same answer that they're going the same speed? Yes. So you have to have work, but not everybody's work is going to look exactly the same, and that's okay. Number 2, if you blend 2 scoops of chocolate ice cream with 1 scoop of milk, you get a milkshake with a stronger chocolate flavor than if you blended 3 scoops of chocolate ice cream with 2 scoops of milk. So it's telling us we would. We just have to explain why. It's wanting us to compare the flavors of 2 milkshakes. Anytime I'm comparing, what do I need to do? Anytime I'm comparing, what do I need to do? Lori?
You need to get them comparable.
Yeah, I need to get them comparable, which means I have to get something to be the same. So this says 2 scoops of chocolate, 2 scoops of chocolate ice cream to 1 cup of milk. Okay, and you get a milkshake. So it's saying this one's stronger. I'm going to go ahead and label that because it's important to know what they're thinking. This one's stronger. Then if you mix 3 scoops with 2 cups of milk. My labels are in a different spot there. That's okay. How can I answer this? Paxton, put that away or throw it away. How can I answer this? What do I have to do before I can answer it? It goes up here, Maya, if you guys are all done with it. I'm trying to compare. So to be able to compare, what do I need? I have to get something to be the same. What can we get to be the same, Paxton? Brant?
You can multiply 2/1 times by
Yeah, so so you're getting cups of milk the same. So I have 1 cup of milk here. I can easily turn 1 cup of milk into 2 cups of milk by doubling it. So times 2 times 2. So that'd be 4/2. So that's my work, but what does that mean? How does that prove that it is stronger? Cam?
There's more scoops of chocolate ice cream.
To every cup of milk. Yeah, so our reasoning would be if we double the first recipe, it would have 4 scoops of chocolate ice cream to 2 cups of milk. If you have more chocolate ice cream, it will have a stronger chocolate flavor because this one only had 3 scoops. Okay, that one had 4 scoops of chocolate ice cream. This one only had 3 scoops of chocolate ice cream to the same amount of milk. There's different ways you could have explained it, but you would have been either comparing 4 to 3, or you could have got the scoops to be the same. And then said something about the milk. Will more milk or less milk make it more chocolatey? More milk or less milk make it more chocolatey, Bryson? Less milk. So the one with less milk would have had the more chocolatey flavor. Okay, so that's one where we have to do the math, turn off our math brain, turn on our common sense brain. Okay, you probably haven't made a bunch of milkshakes, but what have you made that kind of helps you think about that one? Chocolate milk. Okay, you guys have probably, raise your hand if you've never made chocolate milk. Anybody? Are you lactose intolerant?
No.
Does your mom make your chocolate milk for you?
No.
You're old enough to make your own chocolate milk. Okay. Next one, number 3. There are 2 mixtures of light purple paint. Mixture A is made with 5 cups of purple, 2 cups of white. Hopefully you're getting in the habit as you're reading, you set up your ratios. A is 5 purple, 2 white. Mixture B is 15 purple and 8 white. Which mixture is a lighter shade of purple? If I am comparing, trying to determine which one is lighter, what do I have to do? Callan?
You have to get them comparable.
Yeah, I have to get them comparable, which means I have to either get purple the same or white. Lena, what did you do?
I got the whites the same because I did like times 4 and times 6.
Okay, so you looked at 2 and 8 and said I can easily turn a 2 into an 8 by doing times 4 times 4. So that would be 20 to 8. So she got the whites the same. If you use the same amount of white and different amounts of purple, which one would create the lighter color, Reese? If you use the same amount of white and different amounts of purple, which one would make the lighter purple, the one with more, or the lighter shade? The one with more purple or less purple? Less purple. So we are going to say that mixture B from Lena's method, mixture B makes the lighter purple because if you use the same amount of white, it has less purple, would be your reasoning. Raise your hand if you got the same answer but worked it different. Maya, what did you do? Okay, you got the purple to be the same. What did you do to turn the purple the same? Okay, so you multiplied this mixture by 3 to get the purple the same. Oops, I did times 3. So do we get the same answer if we have the same color, same amount of purple, and the whites are different? Which one would make the lighter purple paint, Avery? Yeah, the one with more white. So if you did it that way, you would say mixture B is lighter because if they have the same amount of purple paint, the one with more white would be lighter, or mixture B would be lighter because it has more white paint. Okay, again, your work has to back up your explanation. Questions on that one?
No.
Number 4, tulip bulbs are on sale at Store A for Store A 5 for $11. So that's price over product, 11 over 5 What are they? Tulips, tulip bulbs. And regular price at store B is $6 for 13. Store B, $6 for 13 tulip bulbs. Oh, yep, I did that backwards, didn't I? $13 for 6 tulip bulbs. Is each store pricing the tulip bulbs at the same rate? Explain how you know. What can I do to figure this out? Parker?
You could get it down to a price of 1.
Okay, I could find unit rate on both. Raise your hand if you did that. Okay, were they pretty answers or ugly answers? Ugly, but it's possible, okay? We've been working on decimals all year to prepare us for this. So if we took this down to 1 for both of them, so here we'd have to take 11 divided by 5. Who got 11 divided by 5? Finley, what'd you get?
2.2.
Okay, talking money. How much money is that?
$2.20.
$2.20. So that one wasn't too terrible. Okay, so one bulb at store A cost us $2.20. What about store B when we took 13 divided by 6? 13 divided by 6. Kinley, what'd you get?
2.17.
Okay, $2.17. And that one we had to round. We would have got 2.166666666, and we would have had to round it. Okay? Does that give us our answer?
No. Yes.
What is my question, Emma? What does the question ask?
Which one are they the same price?
Yeah, are they the same rate? Our answer would be no, because store A is $2.20 per bulb. Store B is $2.17 per bulb, if I solved it that way. How else could I get an answer? Or do you have a question? Okay, what's your question? $13 divided by 6. So 13 divided by 6. 6 goes into 3 2 times, so that's 12. Subtract, we get 1. We would add our decimal point and our 0. 6 goes into 10 one time. 4, I'm going to drop another 0. 6 goes into 40 6 times. Did you round? Okay, did you round 16 to 2? Okay, so I'll keep going. So that's 36. That's 4. I drop a 0. 6 goes into 40. Why, if I'm talking money, can I stop? Do I not have to keep going? Cam? I only need 2 decimal places, so I always go out 3 so that I can round. So this 6, Emma, would help me decide what's going to happen to that 6. Does that make sense? Okay. So who worked it different? Because that wasn't the easiest way to get to that answer. To compare, we have to get something to be comparable, which means the same. I would have probably, let's get the tulip bulbs to be the same. What could we easily get both of them to? Finley?
So I had 216 and I rounded the 6 to the 1 and I got 220.
So $2, so you wouldn't round, we only round the third digit, we only change the second digit. We don't round up a whole lot. Okay, and we only round it because we can only have 2 decimal places. Does that, so you had 2.166 at some point? You just said you rounded 2.16 to 2.2. Where are we at? Okay, where's your math to back that? So if that's your answer, you leave it, because that's 2 decimal places. Money is 2 decimal places. But your next digit should have been another 6, which would have changed that one to a 7. Okay, but you should have worked to back that up somewhere. Okay, so if I found the price of 30 bulbs, That also would have been a pretty easy way to get there and no division of decimals necessary. How do we get from 6 to 30? Times 5. So on top, I would have to do 13 times 5. 65. So it's $65 for 30 bulbs there. Here we have to do times 6. Times 6. What's 11 times 6?
66.
66. Do we still get the same answer?
Yes.
That they are not selling them at the same rate and store B is cheaper. Yeah, so we got the same result no matter how we looked at it. Our reasoning would just be slightly different. Okay, number 5.
What are tulip bulbs?
It's a flower, like instead of a seed, you plant a bulb. It's just like a big seed. A plane travels at a constant speed. It takes 6 hours to travel 3,360 miles. What is the plane's speed in miles per hour? That right there tells us we want miles on top, hours on bottom. 3,360 over 6. Trying to get to 1 hour. Divide by 6. What is 3,360 divided by 6, Callan? 560. Do you guys agree? Okay. So 560 is my work. What is my answer for A, Logan? 560 miles per hour. Then at this rate, how many miles can it drive in or travel in 10 hours? I would just expand my equivalent ratios. Kendall, what do we do?
You multiply 1 times 10.
Yeah, we have to figure out the multipliers. 10. What is 560 times 10? 5,600. And that one, my answer is just 5,600 miles. Okay, number 6 was the hardest. What made it more challenging? Maya? There were fractions. What was okay about the fractions, though? Emmett?
It was like quarters.
If you know quarters, if you know money, it made it easier. I agree, okay? They were fourths and halves, which if we know any fractions, it's usually those ones, okay? So even though they were fractions, they were some that we're probably a little bit more familiar with. A pound of ground beef costs $5. So I'm going to start my table. It's $5 for 1 pound. Okay, A asks me how much it is for 3 pounds. Lena, how do I get from 1 to 3?
You do times 3.
Okay, times 3.
And then you also do times 3 up top.
Okay, and what would we get?
15.
15. So the answer to A is $15. Then for half a pound, I'm going to go ahead and just expand this. Paxton, can I easily get from 1 or 3 to 1/2?
You can divide 1 divided by 1.
Is 1 divided by 1 1/2?
1 divided by
Avery?
1 divided by half.
Not 1 divided by half. That's what Paxton just said. Dominic?
1 divided by 2.
1 divided by 2. Think about that number 1/2. Is the fraction 1/2 saying 1 divided by 2?
Yes.
Yes. So 1 divided by 2 equals 1/2 with no math involved. 1 divided by 2 is 1/2. So then on top, 5 divided by 2, if we do no math, we'd get 5/2. Can I say 5/2 dollars?
No.
No, I'd have to divide it out. What is 5 divided by 2? Callan? $2.50. Okay, so that would be $2.50 for a half a pound. Now, from here we can do some logic or we can do math. Okay, I'm going to do the math first and then we'll talk about the logic. in my math, I'm now trying to get to 1/4 of a pound. Using the same idea from the last one, Bryson, 1 divided by what gives me 1/4? 1 divided by 4 is 1/4. So on top I have to do 5 divided by 4. 5 divided by 4 is 5/4 dollars. A good answer? No. Mixed number. What is 5/4 is a mixed number? Emmett? 1 and 1/4. So we can't say I have 1 and 1/4 dollars, but my quarters should be kicking in. Lena?
$1.25.
$1.25. Good job. Now, that's the math. How could my logic have helped me there? My math brain, my number sense. Reese? We're not to 3/4 yet. To get to 1/4.
1/4, you just know that it's 25 cents, and then you can do 25 times 5.
Where'd you get 25? Because 1/4 of a pound is 0.25 pounds, not money. If you know how to get from 1/2 pound, how are 1/2 pound and 1/4 of a pound related?
Yes.
I said how, not are they. They are related, but how, Cam?
1/4 is half of a half.
Yeah, 1/4 of a pound is half of a half of a pound. So if we know the price of a half of a pound, we could have divided it by 2. 250 divided by 2, does that give us 125? Yes. Okay. From here, we're going to use all logic. We're still going to use math, but we're going to use all logic. 3/4 of a pound. How many 1/4 are in 3/4? 3. So I could take 125 times 3, which would be 375. Or, look right here. If you have 1/2 pound of something and 1/4 of a pound of something, how much do you have, Maya? 3/4 of a pound. So we could have added 250 plus $1.25. Does that still get us there? Yes, we could have did some multiplication over here from lots of them. Okay? Let's use that same logic for E. Lena?
Well, we already did 3 times 5, so it would be $15.
So 3 pounds is $15.
And then 3/4 would come out to 75 cents.
So 3/4 of a pound is $3.75.
Oh,
Then you add them. So that would be $18.75 for 3 3/4 pounds. Okay? We could have put, because we know how to multiply fractions, 3 3/4. How do we get from 1 to 3 3/4? Don't overthink it. Callan? 1 times what equals 3 3/4? 3 3/4. On top, we would have 5 times 3 3/4. Is that a math problem we know how to solve?
Yes.
Yeah, we would put 5 over 1 times 12, 13, 15 fourths. Not our favorite math problem. 5 times 15, 75 fourths. When we divide that out, we would get 1875. Okay? So what makes this confusing is there's lots of ways to get to the right answer, and you are familiar with all of those ways. So a lot of times people just get confused on what to do, and it's because you have options. You don't like options. You like one way to do it so you don't get confused. Yes. Okay, so I'm going to tell you what we're going to be doing till next Monday. Emma, did you have a question? How do we get 1875 doing what? This here, 75 fourths. So if you divide it out, 75 divided by 4. 4 goes into 35 8 times. That's 32. I get 3. I'd add a decimal point and a 0. 4 goes into 37 times. I'd get 2, drop another 0. 4 goes into 25 times. Okay, I'm going to clear this. So we are going to be working on a review assignment the rest of today, all day tomorrow, and you have all class period on Monday. Okay? So do you think it's going to be a short assignment or a longer assignment? It's going to be a longer assignment. Did I ever start that? Oh yeah, okay. I thought I forgot to start recording. Give me just a second to pull something up. So it's actually 2 assignments, but it's all over the same thing. It's a review over lessons 6 through 10. Let me find what I need here. Oh, it's this one. The first thing I'm going to give you, it's the cool downs from each lesson. Remember, that's like one problem. I printed them for lesson 6, 7, 8, 9, and 10. So it's 5 different cool downs. It's like one question from each lesson. Sometimes there's one problem and it might ask you a couple questions. Okay? This is just 5th grade stuff. I just put this at the bottom. I'm also giving you a sheet that looks like this. Cam, what do you think that means you're doing in addition to the cool downs?
Khan Academy.
You're doing some Khan Academy assignments. Maya's so excited. Okay, there are 5 Khan Academy assignments. 4 questions, 4 questions, 7 questions, 4 questions, and I think this last one had 5. I forgot to write it down. It's 4 or 5, okay? But you have about 15 minutes of class time today. You have all of class tomorrow and all of class on Monday. Shh, listen carefully. I'm not done talking. Listen so you don't ask this question. Now, you must show work, but you can use a calculator. What work do you think you will show for most of these assignments, Kellen? Probably ratios. Can you show me what you're dividing by or multiplying by? Yes. Okay? Hey guys, listen. You don't have the papers yet, so you can't start yet.
I know.
That's why I haven't given them to you. You can redo the assignments, but you must show work. You must finish all of them before you redo any of them. Okay? I am giving you this work page that you're looking at. I'm giving you that. So you can start with that one. I want you to label the assignments. Okay, so when you get this, the first thing you're going to write down is assignment number 1. And if you want to go up to the top and call that top one 1, so you know which one's which, or you could write the title of the assignment. I don't care. If you choose to redo assignment 1 in the end, you would write redo number 1. Does all of that make sense? So I'm going to give you a worksheet that has the cool downs on it, and I'm going to give you this. All of it is due by the end of the day on Monday. Okay? You do have Chromebooks today. You do not have Chromebooks tomorrow. My suggestion, work on Khan Academy today. Work on the cool down worksheet tomorrow. If you get finished, I do have 12 or 13 Chromebooks. Okay? Does that all make sense?
Yes, ma'am.
Okay.